you so much, Rahul. Rahul, welcome to MLDS. The stage is all yours.
Thank you so much. Are you guys all agented out already? Right? There's so much more to come. It'll keep coming. We need to change that banner, AIM. Call it India's biggest Agentic AI conference. Yes? Okay. All right, so I wanted to talk a little bit today, just, taking a step back, thinking big picture, making sure we are all sort of aligned on terminology that we use. Because what I've realized, reading through literature, reading through media reports, reading through research reports, reading through things that clients are talking about, that there seems to be a lot of terminology that gets thrown around, and it means different things, right? But we are technologists here. This is a developer conference, and we owe it to ourselves to be very specific in terms of what things mean, right? And also look at how the workforce is progressing, right? And what's coming up in the future. So, I don't know, show of hands, how many of you all were at MLDS 2024? Quick show of hands. Yeah? Few people. Anybody remember what I talked about in my tech talk at MLDS 2024? Agents, right? But I talked about agents from a perspective of enterprise software and how enterprise software was going to change fundamentally, right? And how you would have a conversational interface, how you would have dynamic control and data flow, right? And sort of how that would work with tools and interaction, and talking about memory, talking about different aspects of multi-agent framework, etc. I know recently there's been a lot of talk from rich and famous people in the tech world about the death of the enterprise software. Just want to point out, you heard it here first 1 year ago, right? So not to brag, but to say, what you're hearing today and over the next couple of days in MLDS, don't think of it as just another conference. There are things being talked about here that you'll get a sense of deja vu about, in the months and years to come. So keep that in mind. All right. So how would you recognize an AI agent if you passed one in the street? You'll say, Rahul, stop right there. In Bangalore, nobody walks in the street. Right? I'm like, okay. How about at your favorite watering hole, or your favorite coffee shop in Koramangala, 3rd block, all the startup companies that are there? Or more realistically, it's a Sunday morning, and you've taken the trouble to wake up and drive to the nearest overpriced, overhyped, overcrowded South Indian cafe, taken your, ghee puri idli, and managed to find that one sliver of a place somewhere, and you and your significant other are sharing that, right? And your mental state is somewhere between elation that you have found that spot and anxiety at the amount of ghee that got poured into your idli, right? And this tech bro standing right next to you says, I'm an agent. Okay, maybe he doesn't say. He's like talking to somebody else saying, okay, I've built an agent. So the question is, how do you know what an agent looks like? What does an agent do? Everybody is calling everything an agent these days. So it's very important to understand what really is an agent. And some of you might be aware that this term agent has been along for a very long time. It's been applied in the context of LLMs now, but AI agents have been around forever. And there are certain very specific characteristics of an AI agent. It needs to be able to interact with the environment. Interacting means being able to observe the environment and being able to take action on the environment. B, it is able to understand how the environment or the world evolves. What state comes after what other state. It is able to understand how actions change the environment, right? Because it takes actions, so it needs to know what happens as a result of those actions. And then it is able to choose across actions. And how does it make that choice? In the early days of AI, it used to be rule-based. We used to give it rules, saying, if this, then that, right? These are rule-based actions. We then matured to goal-based actions, that I want to achieve this end outcome. I will take the actions that best lead to that outcome. We then evolved to use utilities, reward functions, because an autonomous vehicle can drive you from point A to point B in many ways. Each of them achieve their goals, but there are only a few of those pathways that are short and safe, right? And the utility of those pathways is higher. All right, you all with me, interact with environment, understand how environment evolves, what actions you can take, how that creates a difference, and how you choose between actions. The other component is the learning, being able to continuously learn over time, right? Take inputs from a critic that is helping you to alter how you behave, how the agent behaves, and also an aspect of exploration versus exploitation. What does that mean? So exploitation, so for a model, it's very easy to find one best way to do things and always do that, right? But what that happens is often you get stuck in a local minima. There might be other things to do. Secondly, it propagates biases that are there in your data. So it's important to be able to sort of nudge the model into a space it hasn't seen before or try something new, right? So this whole idea of exploration versus exploitation. So this is what an agent looks like, or an agentic system looks like. A very useful reference and example I can think of is the autonomous vehicle, right? And we'll talk a little bit about that more. But now are we clear that, if you have to qualify something as an agent, these are some of the characteristics. Then you will ask, okay, so what about LLM agents, right? And we talked a little bit about this in my previous, and you'll see a lot of information about here, this. There are some aspects which are based on LLM agents. So there is, of course, the idea of actions, because we said, right, an agent should be able to take actions. And tools. So how do you differentiate between actions and tools? What's the difference? Right? If the output of a task is deterministic, given an input, we know exactly how it processes and creates an output. So a calculator function, for example, or a calendar function, or any very specific arithmetic calculation that happens, right, of a particular KPI or a measure. That is a tool. So tool has deterministic output for given input. An action can be probabilistic, right, where there is some agency in the tool. And we'll talk about agency in the system, and we'll talk about that. Then there's the aspect of planning. So what is planning? So we all know about chain of thought, right? Then there is the aspect of a critic being able to say what's working versus what's not working. There is a reflection after you have performed a task, thinking back to say, is this the best way to do it? There is sub-goal decomposition, so being able to take a goal and break it out. So all of that comes under planning, right? And then there is memory. Memory is usually of two types: short-term memory, long-term memory. Short-term memory is typically in task, in session, remembering all the interactions that have been happening currently, and long-term memory is being able to learn over time, right? Remembering things from before. So these are some of the aspects that you'll see. Now, an agent still is the same definition I had in the previous slide, right? But for LLM agents, these are some additional terminology, and we should try to understand what that means in the context of the broader agent definition. All right, so if you are trying to architect an agentic workforce, right? And what does that mean? So that means that now, typically, all of us work on projects, programs. How do we create a team around that, right? We define a solution, we define the activities that need to happen, we find the people with the right skills, and then we deploy that on that project or program, right? Now you need to do the same thing. You need to think about how you do the same thing for a group of agents. So it's now not just one agent. You are trying to select a group of agents, just like you select a group of humans. And typically, more and more, we will be creating project teams which are combinations of a combination of human and agents, right? So that's what the agentic workforce is all about. And what we have found it useful to do is, this is a complex problem. The previous speaker also talked about it. Getting this to work, right, with just one or two agents itself is pretty complex. Think about getting a workforce together to work properly, right? We have found it useful to break this problem domain down into 3 areas, right? One is the orchestration piece, right? How do you orchestrate all the work that needs to happen? The second is the action piece of what are the specific actions that need to be done, the work that needs to be done, right? The job to be done, as we say. Right? And being able to break that down into components. Some of them are deterministic and they need to be tools. Some of them are probabilistic, which can be agents and multiple different agents with different skills, etc. And then there is the knowledge component. This is the way we do work. Because remember, even today with a human workforce, you expect that workforce to come with some knowledge. There is some fundamental knowledge that would have come to the person just by being alive. There is some knowledge that was learned in school and college. And then there is some knowledge that will be learned which is contextual to the industry, to the problem domain, and to your own company, right? That is your IP. So just like in a human workforce, the work that they perform is a collection of all this knowledge. Even in an agentic workforce, you need that knowledge, right? And being able to decompose this problem into these 3 areas helps you select the right optimal tools and technology, methods, etc., looking at building versus buying. Knowledge for a lot of us can be very IP heavy, where it makes sense for us to protect that. That is our secret sauce that we are bringing to the table, right? It creates new kinds of jobs. So a lot of the knowledge that gets deployed by companies is intrinsic knowledge. What does that mean? It sits inside people's minds. In order to be able to have an agentic workforce that uses that knowledge has to be made explicit. Right? From implicit knowledge, that has to be made explicit. So there is this process of harvesting knowledge of how we work, how we do things, how employees in our companies do things. What are our methods? Some of them are written down, a lot of it is not written down. Right? So that creates a new class of job about harvesting knowledge, which is sitting in people's minds. And there are various ways to do that. But that is one class of work that is getting created, which is almost like a new profession. The other one is this idea of a flow engineer. Have you all heard this term before, flow engineer? Because when you are thinking about how you are going to design your agents, what work is done, what action is performed by a deterministic tool versus a probabilistic agent, and how all of them are orchestrated together, you need to make some trade-offs, right? And I'll talk about the biggest trade-off, which is risk, a little later. But you need to make a trade-off. You have to say, okay, this is a tool, this is an agent. Oh, it's too risky for the agent to decide on this. Maybe I'll make it deterministic, make it a tool, right? And then how those are brought together. What kind of reflection you should have, what kind of critic you should have. Right? So the flow engineer does this, thinking through what are the different aspects of breaking down a particular task, routing tasks through a workflow, making things deterministic versus probabilistic. Okay? Now, it was mentioned in the blurb of my talk that maybe we are moving towards AGI through some of these things, and let me talk a little bit about that. So, like I said, imagine, right? You are in a company of human workforce, right? You have people in your company, what we very bluntly call a bench, right? Not a nice word, but anyway. We have a roster. Basically, we have a roster of people with different skills, right? And then we keep looking at who are the right people to deploy to a particular task. And sometimes we hire people because they have the skills to perform a particular task. Then we have a training mechanism, right? Where we can train people to perform certain tasks. If we find that there is a new task to be done, which people don't have skills, either we acquire people from outside or we train people to do that task, right? And we are continuously having governance and quality control on the work that gets done. Are we all in agreement? This is how we do work, right? We choose people with certain skills from a group of people available to us. We add to that group as required or retrain people in that group. And we provide governance and quality control. In an agentic workforce, it is going to be very similar, right? That for a given task, there will be a roster of agents available. Depending on the task to be performed, you will call upon the right agents and multiple instances of those agents, depending on the volume of tasks to be performed. You will monitor the quality of the work that they are performing, which will then decide, is the set of agents that you have sufficient, or do you need more agents? Or do you need do you need to retrain your current agents? You see the analogy, how it is working, right? But this has to be done with these software agents. Now, how is this heading towards AGI? Same question I asked as agent. How will you recognize an agent if you meet one on the street? How will you recognize AGI if you meet one on the street? Anybody? How will you know it is AGI? Two characteristics, right? Self-spawning or self-replication, the ability to create, a software's ability to create another software. And the second is to be able to train that software to perform certain tasks. So that is the point, the singularity, where we can say that we have reached AGI, where it is able to self-spawn and self-train. Now imagine in this idea of an agentic workforce, you start with a null set. A lot of us like maths, so I also like maths, so I'm talking in terms of a mathematician, right? You start with a null set of agents. There are no agents. You ask it to perform a task. It realizes it cannot perform that task. It understands what agents are required to perform that task. Right? It goes to an agent university and says, can you create this agent for me? There's a piece of software that's looking at, okay, what do I need to do in order to build that agent? And sometimes I might need to go to a human and ask, how do you perform this task? The knowledge management thing comes in, right? So if you can have the vision of the future, right? I'm trying to paint a vision of the future, is where you start with 0 agents and have a self-organizing, self-propagating, self-training network of agents, right, that are able to do a cold start, right? We talk about this, a cold start problem, where it is able to do nothing on day one, but over time is able to build the workforce and train the workforce. All right? Last piece that I will be talking about today. One key thing to remember, and I see a lot of systems being developed today which fail this test. And what is the test? An agent needs to have agency. And what is agency? Dictionary meaning the ability to take action or to choose what action to take. You will see a lot of agentic systems, and you actually go into under the covers and see what they're doing. There is no orchestration. It is a deterministic flow of activities. One agent does something, passes out to another agent. One agent does something, passes. At a minimum, it might be, okay, there are 3 possible agents, you decide which one to choose. But that also mostly is rule-based. You are giving a rule. Right? So there is no agency. If there is no agency, it's not an agent. Okay? So first step, agent needs to have agency, but agency creates risk. Why does it create a risk? Because it is not deterministic. Right? It might choose to deploy methods or take actions which do not align with our morals, our ethics, and our policies. Forget morals, ethics. All companies operate by policies. Right? Every single digital transaction that you perform within your enterprise is driven by a policy which is written down. More so in regulated industries, in banking, insurance, healthcare. Right? So agency creates risk. And what do you need to take care of that is the observability. Show of hands, how many of you took a flight into Bangalore to be here? Were there agents on that? And I'm not talking about Agent Vinod, but agents. There were control system agents. Pretty much 80 to 90% of an aircraft flying is done automatically. But in every single airline, there are 2 human beings sitting and watching it do its task on every single airplane. Once in a while, every 3 months or so, you'll find one article which talks about, can we have autonomous planes and all. It's not happening. Right? It might be technically possible, it's not happening. Why? Because the stakes are so high. That's why even though 80% is automated, there are still 2 people going to sit, and at least 2, sometimes there are more, sitting and watching what it is doing. Right? So observability is key. I'll give you one more example. Autonomous vehicles. When autonomous vehicles, I'm still waiting to go to San Francisco and ride a Waymo. I haven't done that. I've been to San Francisco, but not ridden a Waymo. Next trip, I'm going to do it. Anybody here? Show of hands. Been in an autonomous vehicle? One here. One person there. right? Okay. So when these vehicles were first deployed, there used to be one person in every single car, observing what it's doing and ready to take over. Now we have graduated to a place where there is like a control center, right? Where there are a group of people watching a fleet of cars, right? But it took time to get there. So observability and observation is key, especially when you are giving your agents agency and then asking them to make choices about their actions. Right? Close observation might be required where the stakes are high, and that might need to be continuous, or you might evolve from close observation and scrutiny to more relaxed scrutiny over time. Right? Because, trust me, this is coming in the next 12 months. There will be an agentic system which has agency. It will make mistakes, and lawsuits will happen. Right? Because here's the thing, even with autonomous driving, it is an established fact that on an average, autonomous vehicles will cause much fewer accidents than human drivers. Yeah? But if an autonomous vehicle causes even one accident or one fatality, we find it very hard to forgive it. Find it very difficult. It's just very human nature. This was true in, with elevators also. Or automated elevators, which was not human operated. We find it very hard. And that's going to happen over here. If you give agents agency, they will make mistakes and we'll find it very hard to forgive. Even though we know that on an average it will make fewer mistakes. And we'll generally be better off. All right? So this aspect of observation becomes key. Right? And keeping the risks in mind. What risk is it going to take? Because, and what I am seeing today is that we are all in a rush to establish the capability without necessarily thinking through at every step what might go wrong, what wrong decision, choice, or action might be taken. Is there a way to prevent it? If there is no way to prevent it, is there a way to observe and record it so that we at least know after the fact? Either as it is happening, so we can take over, or at least after the fact. So this question needs to be asked continuously when we are looking at an agentic workforce of the future. And this becomes a key and crucial aspect of such a future. Thank you all. You've been a wonderful audience. I would like to take questions now if you have any.